Welcome to qnawire.
So let's draw a free body diagram of what's going on. Going up, we have the force F. On the other side, we have the force of the ground. That's okay. And then directly in the middle, or not directly, but we have the weight, essentially. Force of gravity. And then this distance here is 0.9 meters. This distance here is 0.5 meters. And of course, this distance here is 1.4 meters. So we can, in order to find the force, force sub L, we can say that's force times 1.4 meters minus the weight, 0.5 meters, minus F sub L times 0.5 meters. This is all going to equal 0. Because this would be net torque. So net torque, you're essentially finding net torque because we know that this is in rotational equilibrium. So we know that the net torque is going to be equal to 0, which means that we can now find F sub L. So F sub L is going to be equal to 650 newtons times, again, 1.4 meters minus 80 newtons times 0.5 meters. And then again divided by 0.5 meters. And so we know F sub L is going to be equal to 1,740 newtons. And to find the force from the ground that's coming from the ground, we can use the sum of forces in the y direction. This is equaling 0 newtons. And we know that force plus force from the ground will be equal to the force of the weight plus the force sub L. And we know that the force of the ground will simply equal now 80 newtons plus what we just found, 1,740 newtons, and then minus F, so minus 650 newtons. And we find that the force from the ground is going to be equal to 1,170 newtons. That is the end of the solution. Thank you for watching.